So we're only going to work through example 1 and example 2 today. Okay? So, using the magic X, what is the first thing that we still always need to be in the habit of doing? Finding the greatest common factor, if possible. Okay? When we look at 2x squared, 7x, and 3, do we have a greatest common factor? No. Okay. So if we don't have a greatest common factor, now we're ready to go right into then the X method. Now on the top, how do we always find the number that's on the top? A times C. Carly, what's my A value in this problem? Nope. What's my A? 2. What's my C value? 3. So my product is 6. So on the top, we're going to put a 6. Okay? On the bottom, we always put our B value. 2 times 3. A times C. What's the very first, what's second step on your paper set? Okay? And remember that our A value is the number that's in front of your squared, and your C value is your constant, correct? So 2 times 3 is 6. Okay. What always goes on the bottom? The B value, which in this case is -7. Okay? Now, you're going to do the exact same thing you did yesterday. On the left and the right hand side, go to the two numbers that multiply to give you 6 and add to give you -7. And they are what? -1 and -6, right? They both got to be negative. Now, this is where it's a little different. Okay? If you look at the next part here, number 5 says, write two factors, both with the same A value that you used to find your X. So when we found 6, we found that by multiplying an A value of what? An A value of 2. So when I go to rewrite this, the number that's going to go in both of my parentheses is a 2x. And I'm going to finish by putting these two numbers just like we did yesterday. 2x minus 1, and then 2x minus 6. You can sit here and ask me why, and I'm not going to be able to tell you why, but this is the process that you're going to use to help get you there. So I'm not going to explain why, but does everybody see where the 2x's came from? Now, here's what I can guarantee you now. That's not your answer. I can guarantee you this isn't your answer. And here's why I can guarantee you that. What's 2x times 2x? 4x squared. We don't want 4x squareds, do we? So now what's the last part of this say? After we rewrite it, then we need to factor each of your binomials that you have left over. So here's my question. Is there a greatest common factor amongst 2x and 1? No. Okay? That's not going to be able to be reduced. Is there a greatest common factor amongst 2x and 6? Yes. They're both divisible by what? By 2. That becomes x minus 3. Now this is why I call it magic. You know what we do with that 2? Throw it away. You might say, well, Mr. Tompkins, isn't that a greatest common factor? No, because when did we factor out a greatest common factor? In step 1. And if there was no greatest common factor in step 1, there's no greatest common factor in the entire problem. That is your final answer. So here's what I'm going to tell you. When your A value is not 1, which is what our focus is going to be for the next 3 days, you will always be able to reduce at least one of your factors. Sometimes, ladies and gentlemen, you'll be able to reduce both. Okay? Now, here's the last thing that I want to talk about, and then we'll move back on here. I always tell students that if you think this is the answer, at least check it by doing, I'm not going to make you do all 4 multiplications, but at least do your F and at least do your L. 2x times x is 2x squared. -1 times -3 is Positive 3. At least check that. Okay, it doesn't take long. Okay, it's often going to help you realize that maybe you didn't reduce something, or maybe you forgot your greatest common factor, or whatever. But that's my suggestion, is always check it with that. Okay, now again, how do I know that this is my right answer? I could actually FOIL it out, and it would give me that. I'm not going to make you do that, but that's the answer to the problem. So this is the new part. Yesterday, these were both 1s, and so you didn't do anything. You didn't really change it from here to here, did you? These are not 1s today, and as I've already alluded to twice, one of those will always be able to be reduced. Okay, so let's take a look at example B. So, do we have a greatest common factor amongst those 3 terms? No. Okay, so let's go ahead and create the x. Briley, what's my a value? 4. Okay, Evan, what's my c value? 3. So the product of a times c is going to be 12. Lily, what's my b value? -7. All right. So what are we looking for here? 2 positives, 2 negatives, or a positive and a negative? 2 negatives. So 2 numbers that are going to multiply to give me 12 and add to give me -7 are going to be -3 and -4. Now, when we go to write it, what's the first number I'm putting in each one of them? Putting a 4. So 4y minus 3 and 4y minus 4. Alright, now we look to reduce. Other than 1, do we have a greatest common factor between 4y and 3? No, that factor is not going to change. Okay, other than 1, do we have a greatest common factor between 4y and 4? Yeah, they're both divisible by 4. So if I divide them both by 4, this is now going to become a y minus 1. This is my final answer. Now, again, I'm just going to show you sometimes, like, as a teacher, this is what I sometimes see. Some students will take your 4y minus 3 and your 4y minus 4. They know they can't reduce the first one. And then the second one, they do this. They just divide by 2, because they're both divisible by 2, aren't they? This is why I always tell people, check your work. What's 4y times 2y? 8y squared. It's not working. I need to get a 4y squared. So this should tell somebody you didn't reduce enough. And anything that you can do to kind of flag that for you is something that I'm going to suggest that you take a look and do it. Okay? Alright, we've got a couple minutes here before the end of the hour. I would like you to try C and D. And I'm just going to walk around and help people who need help. And then we'll check answers when we come back during 6th.